Ultrapure water and water containing PFAS both look identical to the naked eye. There are no visual or optical clues that tell the presence of PFAS in water. So we have to use other methods to identify them. The thing that all molecules have in common is they all have mass. Each unique molecule has a distinct mass. All organic molecules, including PFAS, are made of carbon. Each carbon has a mass of exactly 12. As we start to add things like fluorines and hydrogens, we start to build out molecules such as PFAS. Once we've built that molecule with a unique number of carbons and a unique number of fluorines and hydrogens, we have a unique mass for that PFAS molecule. We use ultra-high resolution mass spectrometry in my laboratory to provide highly accurate measurements of the weight of each individual PFAS. We start with a water sample. The first step in the analysis is to separate our molecules into groups of similar properties. We use a technology called chromatography to do this. Now we send it to the mass spectrometer. In the mass spectrometer, we impart a charge to the molecules, making them ions. This gives us the ability to manipulate those charged particles, the ions, using electromagnetic fields in a vacuum. Once the ions reach the mass analyzer within the mass spectrometer, a very high voltage electrode causes those ions to spin rapidly around a central electrode. The faster they spin, the smaller the mass. We analyze the frequencies of those spins to give us those masses. These mass spectrometers are exquisitely sensitive. They can measure PFAS at concentrations in water down to part per trillion. That's like isolating a single water droplet in an Olympic-sized swimming pool. Back in 2017, we were among the first environmental laboratories in the country to get access to the very high-resolution mass spectrometers available at that time. Recently, we've acquired a brand new mass spectrometer that can scan at speeds 10 times faster, allowing us to identify up to 200 PFAS per second through a 30-minute long analysis. This is going to give us the ability to do comprehensive analysis of PFAS in drinking water across the state of North Carolina. One of the most critical remaining questions about PFAS in North Carolina is tracking down the sources of PFAS in drinking water. We're going to use this new instrumentation to address that problem so that we can understand where the PFAS is coming from and figure out ways to either treat it or shut them off at the tap.